everyone. So nice to see you here. My name is Aysegul, and today I will be talking about D3. And a little bit about me. This is the hardest slide. My name is pretty hard. Um, but you can follow me at Aysegul Yonet at that Twitter handle. And please take a look at the slides at bit.ly sfhtml5d3 because I have a lot of links for you that you can go and look at in the future. And I'm part of this great organization called Any Cannons. Our mission is to teach human trafficking survivors how to code and give them an opportunity to have a meaningful work life. Thank you. Please do check out our website. So what is D3? D3 stands for data-driven documents, as we mentioned. So it allows us to bind data to our DOM elements and then apply data-driven transformations. So what D3 is not, it's not a prototyping tool. So one example of a prototyping tool I would consider is Google Charts. It has a very great user interface. You can give a data point, well, an array of data to a draw function and then give some options, and then voila, you have a graph. And that's not the case for D3 at all. You have to define everything from scratch, and you have to define how the graph should be rendered. So they're comparing examples on these links if you want to take a look and see the difference. So why would we want to use D3 in that case, since we have to do all the work ourselves? The cool thing about D3 is it's super flexible. Everything that you can imagine doing with an SVG, you can do it using D3. And then those changes, every change that you make could be data-driven. And also, D3 has an amazing community. There are lots of free examples on the D3 website that you can take a look, and the codes are included in most of the examples, and you can just copy and paste them. But to be able to copy and paste them, we have to understand some of the things because it gets really complicated real fast. Some of the web standards that, well, some of the things that I will talk to you about is working with SVGs because D3 uses SVGs a lot. And creating the DOM selections using D3, and that includes binding the data to our selections. And then updating our visualizations using the data. And we will also briefly talk about scales, how we can map the data points to our screen. And we will talk about loading external data and how to work with that data. Once I'm done, if I confused you enough, Elijah will talk more about everything that I confused you about. So we work with the web standards, everything that we know and love, HTML, CSS, and SVG. But most of us don't work with SVG on a daily basis, so I will give you a brief introduction to SVG. So SVG stands for Scalable Vector Graphics. So the cool thing about SVGs is that they're very scalable. But that means that we are also drawing things, calculating things on the fly. SVG is just another HTML element, except it has some different rules. For example, you can't nest any other HTML element inside an SVG. You can't put a div inside an SVG. Other things people might think of is that SVGs don't support all of the HTML attributes, like position and float. Also, one thing to notice is that SVG size is browser dependent. So every browser implements the SVG to be a certain size, and you never know what that size will be, so it's a good practice to define the width and height in advance. So let's talk about some of the useful SVG elements. So this is how we create a circle inside an SVG. We have to define like how we will be drawing it. Here we have a center of x, which defines where we will start drawing our circle, and then we have a center of y. So we move from left to right and top to bottom to start drawing our circle. And then we have radius to calculate our circle, and we have to have some kind of color, fill color, to be able to see it. And the rectangles is pretty similar, but all of the SVG elements have their own attributes. So for the rectangle, first we define where we start drawing, and then we have to define the width and height. One really useful SVG element for visualization purposes is the group element. So group element allows you to group things together. And if you want to move your visualization from one place to the other, instead of creating transformations on every circle, you can define the transformation on just the group element and then be able to transform everything at the same time, which is a very, very useful thing. So to be able to work with our DOM elements, first we have to select it, and it's very similar to jQuery selections. We are using the CSS selectors, so we can use the tags, class names, and IDs. But here you can see we are selecting the singular parent div with D3.select, and then we are able to select the child nodes with select all. So in our case, it's a paragraph. Once we have a selection, now we are able to define attributes on our selection. So here I'm able to define an HTML, and I define a style on my selection. Of course, the cool thing is when we bind the data to it. When the data is bound to a selection, each element in our data array is bound to the corresponding DOM element. So the first paragraph will bound to the first one, which is 0 in our case, and the second paragraph to the 1. Once we have that connection, we are able to define any attributes using that data point. So one thing for those of us who are using jQuery, enter is a new thing. What enter does is enter selects the newly added data points, which doesn't have any DOM and data pairing in our current DOM. So if we don't have any data points and if we don't have any elements, we are selecting all of the data points. But if we are entering new data points, if we are adding new data points to our DOM, then that's what we are selecting. And this is the part that gets confusing really fast. So once we are able to select the new data points, we can append new paragraphs that will match with those data points. And from there on, we can use the data to create anything. So here, I'm able to create the text of my paragraphs using the data points, and all my paragraphs are going to tell me what data they have. And there it is. As we need to add more data points to our graphs, most of the time we have to exit the data points as well. So what exit does is a selection, returns a selection that doesn't have any corresponding nodes with the data. This way we can remove the data nodes that we don't have any data points anymore. So this is what we call the update pattern. We first select and then bind our data to our DOM elements, and then we make a selection to enter and append to our stage, and then we have to exit and remove the DOM elements that we don't have any use for anymore. So sometimes we do chain these methods one after the other, and this is a very good thing to do for showing small demos, but people do get confused, because the way the D3 works is that you have a selection, you do some operations over that selection, and then you return that selection to the next method. So here, when we enter an append, our selection might not be the thing that you think it is. If we already have some data and DOM matchings on our stage already, then we are just selecting the new ones that we don't have any data matching. So do use chaining carefully. Once we are all done with our selections, operating on our selection is very declarative and very pleasant. We can set attributes using the data and styles, and we can define event handlings, and we can add or remove or sort any of the nodes and change our content. So things get more exciting when we have some animations. So for that, D3 has transition methods. The transition happens whatever state that we have before the transition and then after the transition. So here we have circles, which we define where we will draw, but they have radius of 0, which will not show up on our screen. And then we define a transition, and we define the duration, and here I'm defining some delay for each one. Afterwards, I'm changing the radius of each circle to be a certain number. So this will give me an animation. So you see, depending on the index number of the data point, I have a delay on each animation. You can apply the transition to anything that is possible. So until now, we use the data points to decide where the circles will appear. And I randomly assign a number. I just multiplied it with 2, and I knew that it will appear on my screen. But this is a big calculation, and you might have a lot of data points, and then you really have to think carefully about it. But thankfully, D3 comes with scaling functions. So what scales does is takes the data set's domain and maps it to a range as pixels in our case. For example, if we are trying to show the distance between 0 to 10 kilometers, and then we want to map that distance to be on our screen to between 0 and 400 pixels, that's what scale is for. And we have a few different kinds of scales. These are the most commonly used quantitative scales, the linear, logarithmic, and power. So here on my x scale function, I'm defining a linear scale that instantiates a new scale. And with the domain, I'm able to define what my data points will be. So I'm starting from 0 and going to the maximum of my data. Also, D3 comes with these really cool array manipulation methods, like D3.max gives you the maximum value on your array. So that's what I'm doing. So I say take the largest number in my data set and then map it to the range of 0 to 200 pixels, which is really cool. Once I have that, I can use that scaling function on my chart. Here, I'm defining the width using that scaling function. So it takes the data point, and then scaling function will return the pixel corresponding pixel on my screen. So to make it clear, so we have this example here. Let's say we have 0 to 10 miles, no, 1,000 miles. And then we want to map it to 0 to 200 pixels. So we give the 0 to 1,000 to our domain of our scale, and then the range will be the pixel range that we want to map it to. So if I ask for what 500 miles will be at on my screen, I can give x scale 500, and then it gives me the 100 pixels. Also, domain and range is setter and getter functions. If you give a value, it will set the domain and range value to it, but if you don't give any value, you get the value that is already in there, so it's a getter function in that case. So here I'm able to get the domain values that I defined earlier. And we have ordinal scales. In those cases where you want to, for example, graph the minions, or any categorical data or names and stuff like that. Here, I give the domain all these list of names from the minion characters, and then I give a range points. So the difference between the range and the range points is that range points returns an array with as many points that I need to have for my domain. If I just gave the range instead, it will keep repeating 0 and 100 for each value that I have on my domain array. So you can see the X scale is giving me 33 for Stuart. And if I console log the X range, then I can see the array that's the range point is creating for me. We also have other ordinal scales like color, where we can define the color of things with the order of our data. So let's put everything that we talked about so far into some good use and create a scatter plot. First thing that we do is select the parent element, which is the body here, and then I append an SVG. And I don't forget that I need to put width and height for my SVG. And I define a scaling function. So I know that my data points in this case will be between 0 and 5, and I define the range to be from 0 pixels to 200 pixels. Once I do that, it's a good idea to have a render function that works with your data, because in most cases, most likely you will re-render things depending on your data. So in my render function, I'm also giving optional radius and color. And I start by selecting all of the circles that exist or don't exist on my stage, and then I bind the data to it. And with the enter selection, I'm able to append new circles to the data points that doesn't have any paragraph nodes. After that, I'm defining some attributes that will apply to that selection. So here, I'm also using these X scale that I defined earlier to find where my circle will be drawn on the X scale. Notice that we can give any static value for any attribute, or we can give functions to for these attributes to be calculated. For the fill color here, I'm returning either the color that I get from the argument, or I can set a default value of red. So let's say I have a very basic data points, 1, 2, 3, and then my data changes. And then I do run the render function twice, first with the first set of data and the second time with the second set of data. So here comes the question. So how many people think that I will have 5 blue circles on my stage? There are no hands, so I'm going to assume you are all thinking that is true. And it's obviously a tricky question. So that's not what happens. So what happened is that we selected the circles and then give the red values, red fill value. And afterwards, we selected only the newly added ones and defined the attributes on them. How did that happen? So if we go back, we are chaining the attribute values to our enter and append selection. So if you remember, enter and append is selecting only the new data points that we did not have before. So to fix that, all we need to do is use our previous selection, which is the circles, which is all of the circles, and then apply the attribute, chain the attribute to that selection. So chaining allows us to go down in the hierarchy, but to be able to go back, we have to use some variable names to have the bigger selection. So we get 5 blue circles. So what happens if opposite is true? Are we covered for that? Our render function works? No. So if we have lesser values, our render function is still not working very well. So although it's changing all of the data points that are already on our stage, it's not getting rid of the ones that we need to get rid of. So for that, we add at the very end, exit and remove, to make a new selection of the exited data points and then remove them from our DOM. Whew, this was the most confusing part, I think. I think people do get confused about the selection part, but once we get over it, everything is super easy afterwards. All you need to do is just use the helper methods. So to recap, we have to bind our data, and we may have to make an enter selection and then append the new nodes to our DOM. And then we can update our attributes. So sometimes you might want to just update the entered attributes too, so that's a case, but you should be aware of. And we can exit and remove the nodes that we don't need. So D3 comes with a lot of other helper methods. So loading external resources is one of the problems that you will run into. One of the methods is D3.json. It gets a URL as the first argument and a callback, optional callback, and gets your JSON data, and you're able to use it to render. Also, there are other cool methods, or D3.csv, that reads the comma-separated values and tab-separated values. Notice that these two functions are getting optional accessor functions if you want to give it. So what it does is just parse the data that you have and put it in the format that you want it to. And it's totally optional. So here I have a CSV file with the days of the week and the donuts that I eat on that day. And I want to get that data. What I do at the very end is just give the URL of my CSV, and I have the accessor function that is defined up here. All I'm doing on my accessor function is changing the string value to an integer value. So everything that comes from the CSV will come back as a string value. So you have to be aware of coercion. So what this callback function will have access to is all of the data on my CSV, but the format is totally changed. Now I have an array of objects where the column names are the keys for every value. Then I can render using that data. So as we saw, you can get the data in any format, any different formats, and you never know what kind of format that you will get your data in. So D3 comes with a lot of helper functions that makes it very easy to work with arrays. And some of them are native functions too. So we have the D3.min and D3.max. Obviously, they give the minimum and maximum value of our array. We have the reduce to aggregate our data. We have keys, and we can merge arrays into one array. And one of the cool ones is the nest one. I think one of the examples after me will be using that. So you can nest your data. And then there are some very statistical ones like quantile and deviation. The other thing that is super useful about D3 is the formatting methods that it has. So D3 has lots of time methods. You can set the time, you can set the intervals, also parse your date object. And also there are all sorts of other formatting methods that you can format strings or numbers, which is super helpful when you're defining any graph with axes and things. So I have some good news. It takes a long time to create a D3 visualization, but there's so many examples out there. If you haven't seen, I guess I have to show it on D3's website. And you can go into any of these charts and then find all of the code below it. So hopefully, after this talk, you'll be able to read through it and make more sense from the selections and the attribute setting. But we have other tools that are making our life easier and that has some predefined D3 charts as well. So MVD3 is one of them, and it's really cool. And we have some other visualization libraries like these. And with that, I want to say I will be teaching a D3 class, all-day class, and you can get a 20% off with the SFHTML5 code here. And thank you all.